Hello everyone, welcome back to the fast track revision series of UGC NET Electronic Science. So in this video we are going to learn about intrinsic semiconductor. Okay, intrinsic semiconductor. Right? If you are first time to my channel, please consider subscribing and don't forget to hit the bell icon to get video notifications from my channel. Okay, so what is intrinsic semiconductor? So generally we know that the semiconductors are classified into two types. One is intrinsic semiconductor, or it is also called pure semiconductor, and second is extrinsic semiconductor, or it is impure semiconductor. Right, so this is the first point which you have to remember. So that is classification of semiconductor. Second, all fourth group elements are called as semiconductors. All fourth group elements are called as semiconductors. Okay, so fourth group elements has 4 valence shell electrons. Okay, so fourth group elements has 4 valence shell electrons. So the popular fourth group elements are silicon and germanium. So silicon, its atomic number is 14 and its atomic configuration is 1s2, 2s2, 2p6, 3s2, 3p2. And germanium, its atomic number is 32 and its electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2, 4p2. Okay, so these electrons are called as valence shell electrons. If you observe here, there are totally 4 electrons in its valence shell for all the fourth group elements. Okay, so the third point which you have to remember is to obtain stability, all the fourth group elements are involved in covalent bonding. Okay, so there are 4 electrons here. Suppose if you take, this is one silicon atom and this is another silicon atom. Okay, so this is silicon atom and this is again silicon atom. So there are 4 electrons in its valence shell and 4 electrons here in its valence shell. So we know that we require 8 electrons to obtain stability. Okay, so we know that 2, 8, 18 and so on. So this is the number of electrons which should be there in the shells, atomic shells, in order to obtain the stability. Right, so in order to have this stability, which is 8, they are going to share the electrons. In its valence shell. So sharing of electrons, the bond which is formed by sharing of electrons is called as covalent bond. So all the fourth group elements, that is all the intrinsic semiconductors or all the semiconductors are involved in covalent bonding. And fourth point which you have to remember is covalent bond is weaker bond. Okay, so covalent bond is very weaker bond. You can easily, by applying external energy, you can break the covalent bonds and make the electrons which are involved in bonding free. Okay, so by applying external energy, you can easily break those weaker bonds, and make electrons free. Okay, and make those electrons free. right? So as I've told you, this is your, and if this is your energy band diagram, right? So this is a conduction band and this is valence band, right? So an electron, so when you apply some external energy on this semiconductor, an electron will jumps from valence band to conduction band by leaving a hole here, okay? So fifth point which you have to remember is non-existence of electron in covalent bond, okay? Not CB, I'll write clearly so that you'll get again confusion. So in covalent bond, non-existence of electron in covalent bond is called hole. This is the definition of hole. So non-existence of electron in covalent bond is called as hole. So hole is positively charged particle. Okay, so all these points are very, very important points. So non-existence of electron in covalent bond is called as hole. Okay, so sixth point, in intrinsic semiconductor, so how the electron hole pair generation occurs? So by breaking the bonds, a hole is left over in valence band and electron will jumps from valence band to conduction band. So in intrinsic semiconductor, right, so number of electrons is equal to number of holes, number of free electrons. We can call it as not the electrons, because more number of electrons will be there. Always valence band will consist of electrons which are bounded to the nucleus. So we should call it as free electrons. So number of free electrons is equal to number of holes. Okay, the seventh point which you have to remember is electrons and holes. Electrons and holes in semiconductor moves in opposite direction. But current given by them will be in same direction. Okay, because electrons are negatively charged particles and holes are positively charged particles, the direction of movement will be in opposite direction, but the current given by them will be in the same direction. Okay, so in the total current in the case of intrinsic semiconductor is due to both electrons and holes, because both charge carriers are present, electrons and holes are present, right? So current given by them, total current in intrinsic semiconductor is due to both electrons and holes, but In is always greater than IP, because mu n is greater than mu p. What is mu n? Mobility. So mobility represents the how speed a charge carrier moves inside a semiconductor. This will learn in separate video about mobility. Okay, so until then keep remembering that even though I is equal to In plus IP, but In is always greater than IP because electrons travel faster. So fast moving charge particle will produce more current. Okay, so that is the reason why. So since mobility of electron is more when compared to hole, so the current due to electron is also more when compared to hole. Okay, so this is the important point. Okay, so the last point which you have to remember in intrinsic semiconductor is, so to increase the conductivity, that is to increase the current in the case of semiconductor. Okay, so what you have to do is you have to increase the temperature, right? So there is no other option, or you have to increase the external force also. So increasing the temperature is not always the best solution. Increasing the temperature is not always the best solution. So intrinsic semiconductors will always have less conductivity. So intrinsic semiconductors have less conductivity. Okay, so therefore it will have less current flowing in the semiconductor. Right, so all these are important points regarding intrinsic semiconductor. Okay, so in order to increase the conductivity, we are going for doping process, and such type of semiconductors are called as extrinsic semiconductors. Okay, so we'll discuss about extrinsic semiconductors in our next video. Right.